Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the FBOSS principle as well as we have also discussed about the Pauli's exclusion principle, and now in this topic we are going to talk about the Hunds rule of multiplicity. So what is this rule and what does it states? Let me talk about that. So before understanding what is Hund's rule of multiplicity, let us understand the statement of it, and then we are going to talk about it in much more detail, taking in a particular example. So now let's start with the first one, that is the statement. That is, when several orbitals of equivalent energy, that is the degenerate state, are available, the electrons first enter all the orbitals singly with same spin, giving half-filled subshell, and only then they start pairing with electrons having opposite spin. So this is the statement, and now let us understand this statement with the help of a particular example. So here basically the example is, suppose friends, if we have a particular orbital having 4 electrons in it, and especially the orbital I am talking about is p orbital. So how we can fill the orbitals? So here basically the p subshell, it consists of 3 orbitals as we know, 1 2 3. So the electrons must be filled in such a manner that is, it should be 1 electron in each orbital, that is, we are filling the electrons singly in each orbital. Therefore we can fill the 4 electrons in this way while keeping the 1 electron in this orbital. This is 1, this is 2, the second one, this is 3, and the 4th electron will be filled afterwards once all the electrons are been filled singly in each orbital. And in this case we see the px, the py, the pz orbital, all these px, py, pz orbitals, they are of the same energy, that is the equivalent with the px, py and pz, they all are of the same energy, that is also known as degenerate orbitals. And now let me talk about the 4th electron, and now the 4th electron will be paired, but here you can see that is all the electrons are having the same spin, that is plus half and plus half, while the 4th electron, when it will enter, it will pair and it will have an opposite spin in this manner. Suppose if we are considering the another example, suppose here I am talking about d5. Suppose if this is the orbital, that is what we have, and the d subshell consists of 5 electrons. As we also know, that is the d subshell consists of 5 orbitals. So here basically I am representing the orbitals in such a manner: 1 2 3 4 5. So these are the 5 orbitals that we have, and what we have is we have 5 electrons. So how we can fill it? We won't fill it in this manner, that is by filling it 1 2 electron 3 4 5. That is not the rule according to the Hunds. So that's the reason that what we can do is we will fill the electron first in this orbital. This is the first electron. Talking about the next one, the next electron will be filled over here, the third will be here, 4th, and then 5th. So this is how basically we should fill the electrons. Now let me talk about the next one. Suppose if we have s orbital, and in s orbital, as we understand, that is there is only 1 orbital, so that's the reason. Suppose if we have to fill 2 electrons, the 2 electrons will be filled, but the thing is, the electrons that we are filling, in that case, one of the electron will be of a positive spin, that is plus half, it will have a value, and the other one will have a spin quantum number of minus half. So that is for sure we have to follow this. And let me talk about what is the use of this kind of filling of electron. Here basically, as you can see, that is while filling the electrons, we are filling in such a manner that is we are filling all the orbitals with singly electrons, and that is how basically the orbital, it will become more stable. And that's the reason that to acquire much more stability, the electrons are being filled in such a manner. So let me talk about the d phi. So the d phi, as we can see, that is, it is a very symmetrical orbital, and we can find here that is all the electrons that are being filled, they are symmetrically distributed. That's the reason this is very much stable compared to that of D9, compared to that of D8. So here basically, suppose if we have another example, suppose if we are talking about D10. So here, as we also understand, that is, it will consist of 5 orbitals, 1, 2, 3, 4, and suppose this is the 5th one. So the electron will be filled in such a manner that is 1, 2, 3, 4, 5. It will be filled singly in each orbital. This will be the 6th one, 7th, 8th, 9th, and 10th. So these are the certain rules, that is what we have to follow, and based on this we can easily evaluate the electronic configuration, as well as based on that we can easily predict the oxidation number, the valency, and such all kind of factors based on the electronic configuration. And for that we have to follow the certain rules, that is FBOSS principle. We have to also follow the Hunds rule, and also we have to know the statement of the Pauli's exclusive principle. So based on all that, these are the rules to fill the electrons in the orbitals. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.